Alright, so number 7, actually let me kind of scroll up here. So this is the email you sent me. You want me to go through a couple of questions. So we kind of walk you through how to read them and which calculator screen you want to go to. So starting with number 7, it says the average daily volume of computer stock. So here they tell you the mean is 35.1. So one of the questions we need to ask ourselves are we dealing with means or proportions? And since we're dealing at the number 35, that's not a percent or decimal, so it's got to be some sort of t-test or z-test or interval or something like that. Okay, so according to a reliable source, a stock analyst believes the stock volume is different. Okay, the word different is the not equal to piece. That's one of the other ways that we know that. So that's where we're getting this from. And as far as the symbol goes, they actually told us to use mu in the problem, so that's why we had to pick that. Construct a 95% confidence interval given at, okay. So I am going, let's see, based on a random sample of 40, he finds a sample mean of 27.4 with standard deviation of 15.1. Okay, so I'm just going to go to my calculator, and this is a t interval. So I'm going to go to stat, go over to test, and look for t interval. Okay, so t interval, and I'm going to type in the stats on that. And so I want to type in the sample mean, which is the 27.4, and then the sample standard deviation, which is the 15.1, and then n was 40, and let's see, I believe a 95% confidence level, and then hit calculate, and it will spit out the answer. So there's the two numbers that go in the interval. Alright, number 12, another one here. Looks like we're dealing with confidence intervals again. So let's see, to illustrate the effects of driving under the influence, police officer brought a simulator to high school. Student reaction time was measured with the unimpaired and then while wearing a pair of special goggles to simulate the effects of alcohol. For a random sample of 9, okay, so we got a sample of 9. The time in seconds required to bring the vehicle to a stop from a speed of 60 miles per hour is recorded. Completes A through B. Normal probability plot and a box plot of the differences are distributed. So here we click the data. Okay, so from here I want to go get the data, so let me go do that. Okay, so here's the data that goes with it. Now notice we have two sets of numbers. Okay, so got to go through the checklist. Are they means or proportions? They're means. No decimals or percents or fractions. Is it one sample or two? So we have a normal and an impaired. Is it independent or dependent? Okay, so independent means I type in the list 1, list 2, and then have the calculator do a 2-sample t interval to figure that out. Dependent sample or a matched pair sample, I'd actually want to subtract these two lists and generate a third list, and then I'd calculate a t interval off the third list. Well, in reading the setup, they're saying the same person did the same activity twice, one with normal and then one with impaired. So it's a matched pairs test. So when I go to my calculator, I'm going to go to my list, edit, and I'm going to type in the first list into list 1, the second into list 2, and then I want to subtract. So let me type that in. I'll kind of start so you can kind of see. I'm just typing in the numbers. 4.58. Okay, so I'm going to type in both lists, and then I'll start the video up again. Alright, now that I've got both lists typed in, I'm going to go up to list 3, and actually I'm going to hold on a second. Let me go read the rest of the question. Okay, so right here in the directions it says compute impaired minus normal. So impaired would be my list 2 minus normal would be list 1. So I want list 2 minus list 1. So that'd be second 2 is L2 minus second 1 is L1. I get that list of numbers, and I'm going to do a confidence interval on that list So I'll go over to stat tests. I want a t-test. Again, this is only for matched pairs. And I'm going to tell it the raw data. And in a matched pairs test, if there is in fact no difference between the two, then I would expect the mean to be 0. Let's see, L3 is where I got my list stored. I'm sorry, I'm doing a hypothesis test. I want a confidence interval. All right, let me try that again. I got close. T interval down here. Okay, T interval. Data. Okay, list 3. Great. Confidence interval 95%. Hit calculate, and voila. There are the two numbers that they're asking for. All right, moving on. All right, baseball league. Okay, I'm just jumping right here. I already noticed that there's 2 means and 2 standard deviations, so this is some sort of 2 sample test. I jump straight to the numbers 6 and 4.3. Those are means, not proportions. I don't see anything about a population. So this is all sample data, which means I'm looking at a 2-sample t-test, and they want me to calculate a p-value. So without even reading the question, I know it's a 2-sample t. So I'm going to come over here, go to stat, test, 2-sample t-test, and I'm going to type in the stats. So I just type in the numbers they gave me. So 6 for the first mean, 3.5 for that. I actually do have to read it to figure out what the n is. I don't see n. Let me go back in here. Designated hitter, typical weak hitter, and was bat. Scoring more runs. An interleague play must be bat. Okay. Expected with lower runs. Claim this test. Okay, so I actually need to go look at the data and figure out n. So let me go get the data so I can figure out how big the sample size is. Okay, so when I open it up, I got this chart here. It looks like the same number, so once I figure out how many total numbers, then we're good. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So there's 5 times 6, so there's 30 numbers here. It looks like the same setup. 1, 2, 3, 4, that 30 numbers there. Okay. So when I come back in, I've already got 30 in each for sample. What is that? 4.3 and 2.7, and then it also has 30. Let's see, are we given some sort of direction in this? Does the designated hitter result in more score runs? Okay, so A came from the designated, so I expect A to be larger than B, so that would be greater than, which it's already highlighted, and then I just want to hit calculate. Okay, and it wants us the first 3 decimal places, so 0.019 is what I'm getting. That actually should round up to 2, but alright, whatever, it's close enough. And anyways, so our level of significance is 0.01. Since this is actually bigger than that, so what that level of significance measures is what % do I get excited about and say I've got evidence for something. So and we're defining at the beginning that it's got to be 1%. So if I only get excited if it's 1% or less, and I've got a sample that shows up 1.9%, even though it's small, it's larger than what I defined as the significant level. So therefore, we wouldn't consider this to be significant. So there's not sufficient evidence to suggest that anything interesting is happening. So we are going to fail to reject the null. So that's what that says right there. Okay, moving on. Number 14. Let's see. We have experiment control. So we got a 2-sample test of some type. Set up a confidence interval of the difference of means. Okay, and then I just have to clarify if this is a matched pairs or not. I'm going to say most likely not, because with experimental and control, typically those are not the same sample size. Let me just actually go back and read it. A study was conducted to determine the effectiveness of a certain treatment. A group of 112 patients were randomly divided into an experimental and control group. Let's see. So it's two different groups. They didn't get the same treatment. One got the experimental treatment, one didn't get it. That's why they're called control. Sample sizes are different, so already I know I can't do a matched pairs on this. So this is just a 2-sample T interval. So let me go, oops, let me go to 2-sample T. Interval. And I input the stats. Okay. My mean is 11.2. My standard deviation is 6.4. My n is 51, and then just input the same numbers. So 3.4, 6.6, and 61 for the control. 95% confidence. And let's do calculate. And there we go, 5.36 to 10.4. And so what does that mean? That means we are 95% confident that the true difference is somewhere between 5.6 and 5.36 and 10.24. So anyways, there's that. And then last but not least, number 18. This time we're given some sort of matrix here, so we're comparing different categories against itself. So to calculate that p-value, that's the only tests we know of that do that are chi-squares, and it's either independence or homogeneity. It doesn't really matter. Yeah, they said independence here. So actually, I'm sorry, they do force us to check. Homogeneity is one is different than another. Independence is whether they're independent or dependent. So you got that part right. As far as the p-value goes, I need to go to my calculator, and this time go to matrix, go over to edit, and this is a 2-row by 3-column, so it's a 2 by 3, and then I just need to type in the numbers. So 105, 84, 61, 144, 101, and 73. Alright, so once I've got that typed in, then I'm going to go over to test and pick a chi-square. Okay, so keep scrolling down until I see chi-square, chi-test right there. And then I've put mine in matrix A, hit enter, and it gives me the p-value of 0.736 right there. And that's larger than any of our alphas, so there's not 73% is not anything interesting, so we definitely are going to reject the null on that. Okay, then on this one it says construct a conditional distribution of opinion by age and draw. Okay, so I go up to our chart again. So they're saying organize this based on age. So I need to add up each of the categories, again by age. Okay, so I want to go figure out how many total are in each column for this one again. So in age. So if I add up, let me clear out that. So I'm going to add up 105 plus 144, gives me 249. And I'm at 105 divided by 249. And 144 divided by 249. And so that's where I get, let's just see that again. So we get 0.241 right there, and then 0.578 right there. And then repeat. Let me go up to the 38 to 49 and do the same thing. So 84 plus 101, and then want to divide 84 by I'm sorry, let's try that again. Oops. I said it, but apparently I didn't type it. 84 plus 101 Okay, so 84 divided by 185 and 101 divided by 185. And that should give me the 2% that match down there. There you go. There's those two numbers. And then I'm going to kind of stop at this point. So the last part is to identify the graph. So once I've got the numbers, then I just kind of look and I see that, well, the against is higher. So against is higher there, against is higher there, so we're good. Against is higher here, but they're very similar percents. So they should be a little bit higher. Should be fairly similar to each other. Now this one, if you look at it, the vertical scale's off, so they're counting up to 100, whereas here they're counting by percents. We want it to be where they're counting by percent, so they got up to 0.7 there, and there they got almost 150, which if you're talking about percents, that doesn't make any sense. So hopefully all of this helps.